All right, this is the isosceles. Okay, so the base angle, they are equal. We know that. But what about this angle? This angle is what? Exterior angle, right? So how can you find the exterior? Exterior angle is equal to the what? Sum of what? Remote angles. A plus A is what? 2A. Okay? This angle is 2A. Can you find something on here? Inscribed angle and center angle. What's the difference? This center angle always twice of what? Inscribed angle, right? So you can say center angle is 2 times inscribed angle. For the what? Same arc, right? For the same arc. Is it okay? In general, this is very special. In general, when you have a right arc over here, we have center angle, another inscribed angle, right? This is inscribed angle, this is center angle, okay? Already what? If this is 80 degree, inscribed angle will be half of this angle, okay? For the same arc, this is same arc, always 40 degree. It is okay? So we're gonna go over a little bit about this. I'm gonna use, okay, some class note over here, okay? Just give me a minute. Oh, this is wrong, very wrong. Oops. Okay. Take it over here. It's a class note. In January, when you have circle, this is center. I'm gonna choose what these two arc A and B. This one you said arc A and B, okay? Yeah. They have center angle. It's okay. They have a center angle now, and also they have what? Inscribed angle too for the same arc. We already know that inscribed angle 1/2 center angle. Center angle is what? 2 times inscribed angle, same thing, okay? So we're gonna, in general, we prove this one. I'm gonna prove this, okay, in January. We're gonna make some line over here, okay? I'm gonna make some line. That's it. This is diameter, right? You can see a triangle A, I'm gonna use P. APO triangle, APO, and triangle BPO are isosceles. I accept, because what these two sides are congruent. These two sides are congruent. They are all radii, isn't it? Radius, right? Okay. Now let's find out in January. Okay, if this angle is A degree, this angle also A degree, isn't it? This is also A degree. What is the measurable angle? AO, I'm going to use this is C, AOC, this angle. This angle, exterior angle, okay? A plus A, isn't it? Exterior angle is always A plus A is 2A. Now take a look the other side angle. If this angle is B, this also angle is B, right? This also angle is B, because it is isosceles. This is also an exterior angle for the other side triangle. B plus B is 2A, isn't it? Is it okay? B plus B is 2A. Now finally, you can see in January, inscribed angle equals A plus B, right? Over here, can you see that? This is inscribed angle for arc AC, okay? Then A plus B. Now, what is the center angle for the arc AC? Same, I'm sorry, AB, right? AB. Okay, I'm gonna make it clear. AB. Now, okay. Center angle for arc AB equals how much? 2A. How about this 2A? This 2B, right? I'm sorry, this is 2B. Okay, B plus B, 2B. So 2A plus 2B equals 2 times A plus B, right? Now compare this one. This is inscribed angle. This is inscribed angle, but this is center angle is already 2 times of inscribed angle, right? That is true. That is true. Another one over here. For the same arc, if we have same arc, A and B, inscribed angle, all of the inscribed angle. Inscribed, so many inscribed angle, they are inscribed, so many. But they are all congruent, equal, okay? Because we know that for this AB, it should be only one center angle, isn't it? The other one is already what, half of a center angle. It doesn't have, it can be over here, it can be here, it can be here, it can be here, right? It doesn't matter. They are all what? Half of a center angle, okay? So another theorem is inscribed angles or inscribed and inscribed or inscribed angle for the same arc are congruent. Okay, that's the rule. Okay, so we just finished center angle and inscribed angle, right? What's their relation? All right, center angle is twice of inscribed angle, or inscribed angle is what? Half of center angle. Okay, that's it. Okay, now go back over here. All right. Okay, we know that triangle DAB isosceles, because we know that two sides are radius, okay? Our radius are congruent, okay? That's why that is isosceles, okay? Triangle. So exercise 2, I think we don't need this one, right? Okay. AM, what is the AM? Where is the AM? Okay. Oh, these are different questions, okay? That means, this means what? M is just center, okay? M is just center. M is just center over here. A is on the circle over here. This is radius. Diameter is 74, radius is how much? 2x plus 7 equals half of this one, right? The radius is half of the diameter, 37, isn't it? Is it okay? So you can find the radius quickly, okay? So x equals 15 is the value of x over here, okay? Now we got the inscribed angle, okay? We just finished this one. Inscribed angle, where is it? For the same arc. If we take this same arc, A and B. Where is inscribed angle? This is inscribed angle. Also, this is inscribed angle. Is it okay? Yeah, that's inscribed angle. They are all what? Congruent. This one and this one, they must be equal, right? Because what? This is inscribed for the same arc, okay? That's it. Now, exterior angle. You know the exterior angle, this angle is exterior angle. When you extend it one of the side, this is up to here, this is a side, we can say side. When you extend it to measure exterior angle, okay? When you extend the line over here, this is now we said secant, okay? So this line, another side over here, we have two angles. One is angle, the other one inside angle. This angle is what? Exterior angle. Inside angle, interior angle. Is it okay? Interior angle. But this is what? Adjacent interior angle of this angle 3, okay? This angle is what? Adjacent interior angle, okay? Adjacent. Okay. Adjacent interior. But what about the other two? Remote, non-adjacent, or remote interior. We have two remote. Okay, we have two remote interior. Okay. Okay, 1 and 2. So exterior angle is what? Sum of these two remote interior angles. Is it okay? So angle 1 plus angle 2 equals angle 3. Okay, that is the exterior angle here. That's it. Okay, the next one, we know that angle BAC. Angle BAC is the center angle, right? This is the angle BAC is the center angle. Angle BC, where is the angle BC? Angle BC over here, right? This one is the measure of BC. This is length of arc, but this one is what is that? That means the angle, okay? That means the angle. It is okay? All right. Oh, BAC is right, not this. BMC is BMC. BAC is over here, okay? BAC over here. Okay. So if this is a 60 degree, that center angle for the same arc BC, when you extend it, this one, the half of this one already 30 degree, okay? So this is also 30 degree. That's why exterior angle is what? 30 plus 30 is 60, isn't it? Okay. Sometimes we use some numbers on the arc inside the 60. So complicated, so messed up. Instead of using this angle in here to make it right easy, better looking, we use this number over here, 60. Okay, that means what? Center angle 60. Okay, center angle 60. So this angle, probably that center angle, this is what? On the arc, we mark this 60 on the arc, that we said what? Use this one. Measure of arc on the arc ABC, okay? That meaning. Okay, can you see it over here? Measure of angle on the arc BC. That's the meaning, okay? So if we have an angle over here, that means what? Center angle, okay? All right, so correct name is a measure of what? Intersect the arc. This much over here intersect the arc, right? Another exact name is a measure of intersected arc. Okay, that means what? Measure over angle AB. That is not length. M is what? Measure, means what? Angle, okay? That's the angle. All right, now we go next. Okay, this is we did already, okay? This is we did already. So this is all what? Okay, you're gonna take a look at it. Angle BAC. This is angle BAC, isn't it? Angle BAC, inscribed angle, right? Oh, angle BC, put angle BC. Okay? Where is this? They must be over here, right? Actually, this is what? Same angle over this one. We just over here. Measure of angle BC on the arc. We use this one, okay? That means what? This angle, center angle, same angle. Okay? All right. Now we're gonna have some practice number exercise 4. Now take a look at exercise 4, okay? How we use inscribed angle and center angle. Measurable angle MOP. MOP, this one is 118 degree, okay? Explain measurable angle MNP. Wow, MNP. This angle. How much is it? How much? Or maybe we can go, they use the Q, maybe you can use Q too. Can you show me here? Or maybe the other way is better, okay? The other way is better. This is what it is. On the arc, this angle is inscribed angle, we know that. Okay, everyone agree, right? This is the inscribed angle, right? Inscribed, because this is one. We have an arc. Where is the arc? Oh, this arc, I'm going to use it, red. All the way down. All the way. Oh, this arc, this is what? Inscribed, okay? That's fine. Oh, where is the central angle? We know that inscribed angle half of central angle, right? We know that. Oh, where is central? This central angle. Oh, this central angle is more than 180, right? It doesn't matter, okay? Because this arc is more than what? Longer than semicircle, right? That's why central angle more than 180. Okay. So this angle is how much? 360 minus 118 equals 2. 5 minus 1 is 4. Okay. And 3 minus 1 is 2. Wow, this one is what? 242 degree. Okay. That is just center angle. Maybe you can write down on this arc of here 242 degree. So if we use what the measurable angle for MQP, maybe you can say this one is the exact same as what measurable angle MQP. Isn't it? You do this one. If you don't write down P, maybe sometimes it indicates. If you use only MP, maybe, but you can indicate this side, okay? MP. So major arc, okay? Greater than the large one is we have to use one more letter over here, okay? Q. This Q indicates what? Direction. Oh, we gotta go this way. Is it okay? That's why we have a 3-letter over here, okay? All right. So now we focus on how we got inscribed angle. Inscribed angle equals how much? Half of this central angle, okay? So 1/2 times 242. Okay, how much is one? 121 degree, isn't it? Is it okay? 121 degree. So another one up here. When you have this arc, when you have write this arc, okay, this is circle, we're gonna make 2 arc over here and over here, AB. Okay, so one arc is what? Longer. One arc is longer. The other like a small. This long arc is we said major arc. Okay, small one is minor arc. They have different name. Okay, but this minor arc can be expressed what? Can be expressed just what? AB. That's okay. This is AB. This is minor arc. Always only 2 letter. Major arc we cannot use AB, right? AB is what? Represent minor arc. 2 represent major arc. We're gonna give the other 1 point. This one is P. Because direction on this side. Okay, so minor arc is what? B, P, A, or A, P, B, R. Okay, The major arc is a little different expression. It is okay? All right. Now exercise 5, okay? Now we're gonna do an exercise 5 over here. Take a look. In the diagram of circle K, yeah, circle K, that is the name of a circle. Always we use, right? We use center. This is the name of circle. Every circle has a name, right? Circle K, circle P, circle O, okay? The letter should be capital, okay? RS is diameter, we know that. The ratio of measure, oh, this measure is what? Angle, okay? RT, this is the measure of angle, RT. I'm going to use 8 degree, okay? That's fine. That means what? Central equal to central angle, okay? Instead of this one, central actually this one. This center for the same arc. This angle A. But when you use this inside of here, very complicated, okay? The diagram is messed up. That's why we use this angle on circle, okay? So I'm going to delete this one. Much clean, isn't it? Much clean. All right, now the next one. Measure angle TS. Where is the TS? This one, small, right? TS is 2 letters, one. Major small one. TS. And what this is B0. Okay, that's the center angle, right? Okay. You know that some of these two center angle is what? 180, right? 180, isn't it? Actually, I'm going to write it one more time. This is the A. This is the B. You know that A plus B is the 180, isn't it? Is it okay? Because what A and B represent center angle. It is a center angle, okay? All right. Now I'm going to delete, okay? That means center angle. Don't forget this one. So we know that A plus B, A is 2, B is 7. You can use 2K plus 7K using the K, right? Right? Or you can use the unit. 180 divided by 2 plus 7 unit. This is the ratio unit, right? Unit ratio. 9 unit. 9 unit forms a 180 degree. Each unit is what? 20 degree, isn't it? You can use this one too. But this is okay too. When you put the right some little K over here, okay, that is now actual dimension, but we need to decide the value of K. 2K plus 7K is how much? 180 degree. 9K is 180. K is what? 20, isn't it? Now put this number 20 over here. So this one is 40. The other angle is 140. So this is a 40. This is a 140, okay? That's it. But it's simple, right? Okay, the next we explain wide angle TWS. Wide angle TWS, this angle, and TRS, this angle. Why they are same measure? How can you explain? They're both what? Inscribed angle for the same arc TS, isn't it? Because you can write down over here. B. No. Because they are inscribed angle for the same arc. That's why. For the same arc, what is it? TS. You know, I'm going to do this for the same arc TS. Right. They are equal. Okay? Because for the same arc on a circle, always inscribed angles are congruent, always. Okay? That's all. Oh, we got now minor arc, major arc. Okay. Take a look over here. Name the minor arc. I'm going to make right some line over here. Oh, this is half and half. Wow, which one is minor? Which one is major? When you divide this one, which is minor? Oops. Trouble, right? But in this case, we don't say minor, major. We just say semicircle, okay? Okay, maybe I'm going to divide this way. Forget this one. Oh, now we have these two points will divide the circle into two arcs. One is the arc, small one. The next one is the big one, okay? Small one is the minor arc. Big one is major arc. You can make a minor arc are the A to B, right? Only two letters. That is a minor arc. Where is the major arc? Major arc use what? 3 letters, right? Which give us direction. You can use by any point. Oh, we have 2 letters over here, right? Same direction, the other side. Maybe you can choose anything. A, C, B, right? That is a major arc. It is okay? That's the major arc. That's all. Okay, we just finished right center angle, okay? All right, take a look over here. We have some practice over here. Circle B, okay. I'm gonna use the exercise 5, okay? Because this is very simple, okay? Inscribed angle already half of the center angle. That's it, okay? So exercise 5. Okay, everybody try this exercise 5. Measure angle ADB. Oh, it is 112. What is the measurable? Oh, this one is what? On the arc. It doesn't matter where is the arc. This side only we use 2 letters. That is a minor arc. What is the measure of this one? Anybody know? Anyone know this one? Anybody can give us the answer? What is the measure of angle of arc AB?
112.
112. They are called. Oh, this angle in also was center angle equal, right? Oh, we know the 112. What is the measure of angle ACB? Oh, this is my major arc this side. Oh, this angle, right? Same thing. How much is that? Everyone knows this, okay? 360 minus 112, 248 degree, okay? Yeah. This side is, we said, measure of angle, ACB, not length, okay? M means what? Measure of angle. This is what? 248 degree, okay? It's very simple. Okay, now, okay, go ahead.
Can you go up to exercise number 3?
Number 3, where is number 2? Oh, this one number 3. Yeah.
Oh, never mind. I don't need it. Never mind.
Okay, so number 3 means well, how we represent okay minor arc and major arc. That's okay, right? Okay. All right, now take a look over here. What? That is too much, right? Unnecessary examples. Okay, what type of triangle ACB? Okay, C is between A and B, anything. ACB. Oh, this is important too. What is this triangle? What is this triangle? Anybody can tell me about this triangle? What is this one? Center angle is 180. I'm gonna write on the right arc 180. Oh, this side is okay too. This center angle is 180. What is the measure of this angle? Can you give me the measure of this angle? Half of the what? Center angle, 90 degrees, isn't it? Is it okay? This is what? What about this one? Also 90 degrees. because they are inscribed angle for the same arc. 90, 90, 90. So, and the triangles built on this diameter always what? Right triangle, okay? This is also what? Always right triangle. It's okay? Always right triangle. All right. So maybe I can give you some puzzle. It's not puzzle. Few years ago, Google, you know, the Google, right? Very big companies. When they have interviews, right, with some students, they give these questions. Maybe you can solve this one. This is right angle. You know the Google chairman, right? He's very genius. Okay. But this is tricky questions. But he knows why it's tricky a lot. It's very simple, but sometimes we, you know, forgot something. Take a look. If this is 10, eight. This is height. This is right angle. What is the area of this one? Area of this triangle. Triangle ABC. Area of triangle ABC. How much? The first one, I'm going to give you. Choice 1, 80. Choice 2, 40. Choice 3, 20. Choice 4, undefined. Okay. Anybody know this area? Okay, give me the answer.
40.
40, okay. Any other? What about Jonathan? What about Dan? Daniel?
Yes.
Okay, what is the answer for this one? Okay, where is Claudia? Okay, the answer is 4 is the answer. Okay, Eunice. Why the answer is 4? Can you get something on this figure? When you have a right triangle, okay, take a look. When you have a right triangle, this is what? Diameter is 10, right? Okay, this diameter 10. What about this one? What about this one?
5.
This is radius, right? Okay, radius is what? Always 5, isn't it? In the middle is 5. The other one is what? Less than 5, okay? Or less than 5. This is the same thing. This is 10. This is right angle. This one cannot be what? More than 5. So this is what? Undefined. Okay? This is the wrong figure. Okay? This is the wrong figure. Can you see that? This one should be what? Less than or equals 5. Okay? When you have to be right triangle, it can be more than 5. Can you see it over here? Yes? Okay.
Yeah.
Good. Okay, now number 2. Okay, now we're gonna try number 2. Okay. Measurable angle B is 180 degrees. This is what inscribed angle, right? Inscribed angle. So we're gonna find out the measurable angle where it is. Find the D in this quadrant A, B, C, D. We're gonna find another D over here, okay? another deal here. Any point is okay. Yeah. What is the measure of this angle? How can you find this one? How can you find this one? All right, this is inscribed angle. I'm gonna find, okay, center angle here, okay, for the same arc center. What is the measure of this angle? Twice of this one, right? 216, isn't it? Is it okay? Twice this one. What about the other side? How big is this angle? 360 minus 216. How much is one? 144, right? This is a 144. Can you see that? 144. Now this inscribed angle is what? Half of a 144, right? So 144 divided by 2 is just 72, isn't it? Can you see that over here? What happened to this angle? What happened to this angle? Sum of these two angles in quadrilateral, okay? Sum of these two angles always 180, okay? So you can say this is what, okay, this quadrilateral, right? They are all inscribed in circle, isn't it? Okay, I'm gonna write down when the quadrilateral, okay, when quadrilateral. Inscribe the circle. We said cyclic. Okay, we said cyclic. The quadrilateral is a cyclic quadrilateral, okay? Quadrilateral. In this cyclic, I'm gonna write down, in this cyclic quadrilateral now you understand the cyclic, what is the cyclic, okay? This is all right, inscribed, okay, circle, isn't it? In cyclic quadrilateral, sum of what? Opposite angle. Is always 180 degree, okay? This angle plus this angle 180, or this angle plus this angle also 180. It's very interesting, right? Okay, so if you know this one, if you know this formula, just this angle is how much? 180 minus 108 equal 72. I'm going to explain this one again, opposite page, okay? Where is it? I'm going to use this. What is secret? We have circle. 2 points. This point, one is inscribed angle here. The other inscribed angle over here. Now I'm going to take this is what? A. The other side is B. You know that A plus B equals what? 360 degree, right? Okay. The angle about a point is 360 degree. Is it okay? Now, this is what? Inscribed angle, half of this center angle, not B, okay? So this angle is what? A over 2, isn't it? A over 2. What is the other side, the inscribed angle? Half of this center angle, B over 2, right? Now, take a look. Sum of these two and inscribed angle, A over 2 plus B over 2 equals A plus B over 2. You know that A plus B is how much? 360, right? 360 over 2 equals always 180 degree, okay? It doesn't matter A and B, how big, how small. Anyway, the sum of these two inscribed angle is cyclic quadrilateral. Only cyclic quadrilateral, okay? Always 180 degree, okay? You have to memorize this one. Later we summarize this one more times, okay? Right now, go back to work. Circle is a very interesting figure, okay? Circle is very interesting. When you go to college, you can see a lot of circles. Now take a look. Now everybody try number 3. Okay, everybody try number 3. The next one, I'm gonna give you one more shot. When you have two lines are parallel, these two lines are parallel. What happened? What happened? This arc, this length, this arc, they must be equal, right? Okay, they intersect what? Congruent arc. So kind of parallel lines intersect. Okay, congruent arc. Already they are equal. This length is equal. And also when you make the line, chord also equal, okay? I'm going to just congruent or congruent chord. You can say congruent chord, both. Is it okay? All right. So same length. I think we need this one too, okay? Angle, measure angle BC is 58. BC is on the arc. I'm going to write down on the arc. 58 degrees. That means what? Central angle. Another measurable arc D is what? This, the other side is 142 degrees, isn't it? From here to here, right? 142. Determine the measurable angle CFE. Where is CFE? CFE, this angle. Right? This angle. Oh, we need this measurable arc because they are equal, right? Because they are parallel, isn't it? So this angle, the other angle should be equal. So all around the circle is 360, isn't it? Now take a look. Now even each one. If this is x, this is x. Oh, that's one. 360 minus 58 plus 142. That is 160. Then can you see that? 58 plus 142 equals 200. Okay, 200. 360 minus 200 is 160. But each side from here to here, they have same length of arc. It has what? Same center angle, right? Okay, so each one is 80 and 80. This side 80, the other side 80. Is it okay? The other side 80. So this 80 is what? Center angle. This is the inscribed angle, isn't it? So this inscribed angle is already half of this center angle. It's going to be 40 degrees, isn't it? So the answer is 40. That's it, okay? Okay, now we're going to have number 4. Now take a look at number 4. After this, okay, we have break, okay? Don't worry. All right, number 4, we have a circle K, diameter CD. Maybe you can draw this is circle K, diameter and CD. You can use diameter and CD. This is K. Point is located on circle. CE is 16. So CE is 16. Okay, maybe CE. That is 16. All right. And DE is 30. DE is 30. What is the length of the radius of circle? Oh, we know that this triangle is always a right triangle, right? Because this right triangle built on this semicircle, which is what? Diameter, right? Any triangle is built on diameter, always the right triangle, because this is center angle 180, inscribed angle 90, right? Oh, this is the right triangle. You can apply Pythagorean theorem, okay? So diameter square, okay? Diameter square equals how much? Diameter, okay, square root 16 square plus 30 square, isn't it? Is it okay? So how much is this one? How much, can you see that? Fifteen square is what? 256. 30 square is what? 900. When you calculate this one, 1156. What is 1156? What is that? 34. Yes? 34 times 34. 136. 100. 1150. Yeah, that's correct. This is 34, right? The length from here, diameter will be 34. You know that this is the 8, 15, that is 17, right? That is right triangle triplet. 8 square plus 15 square equals 289. This is a times 2 times 2 times 2. That's why you got the 16 and 30, right? So this one should be 34. Okay? This is one of the one. Right triangle triplet. Is it okay? All right, so radius is half of the 34, right? The radius is equals 17, okay? Radius is now 17. Okay, now number 5 is all yours. Try number 5, okay? Find out the answer. What is the measure of angle AE? This angle, okay? We're gonna measure this angle AB, AE, which is what? Central angle, okay? Maybe you can find this angle, right? Same thing, okay? So, everybody try this one, okay? After this, we're gonna have a break, okay? Measure by angle C is given 119 and the BEAD perpendicular. Oh, this is the perpendicular, 90 degree. Determine the measure by angle AE. Where the AE? Oh, this one. Write down. That is the center angle, isn't it? Can you see that? That is the center angle. That means what? Center angle. If we have inscribed angle, you can find the center angle what? Because center angle twice of inscribed. We already inscribed this angle. We need to find this angle. Isn't it? Our goal, find this angle. How can you find this angle? How can you find this angle? You guys have any idea? You guys have an idea? Units?
Do you? I said the angle G is a right angle.
Angle G, yeah, that is the right angle.
And then because angle AFE is half, that's 45.
No, this is right angle, it's not center angle. Center angle what? We have a center over here, okay? I'm going to give you a tip. This is right angle. If you know this angle, we can find this angle, right? Sum of these two angles 90. How can you find this angle? Eunice, can you give me some idea? just before we use, okay, cyclic quadrilateral. If this angle is 190, can you find this angle? Sum over the opposite angle of this cyclic quadrilateral already 180. Yes? No? Do you remember?
61.
Yeah, 61, right? This is 61. Okay, so what is this measurable angle? That is the right triangle. Sum of two, the other acute angle is 90, right? So 90 minus 61 is how much?
29.
29 is the answer, okay? So this one measurable angle, not yet, okay? But this angle is 29. So measurable angle A is what? Central angle, okay? That's the central angle. Always twice of this angle, okay? So 2 times 29 equals how much? 58 degree, okay? Can you do that? Okay, now we're gonna have some break, okay? So after we break, we continue, okay? Now I'm gonna finish with the rest of them, okay? It's not much, but we go slow and finish this one, okay?
Excuse me.
Okay, go ahead.
Sorry I left.
Mm.
My computer died.
Oh yeah, no problem, that's okay. Yeah, many of our friends, okay, many of your friends have no still power, okay, so still they are absent today, okay? That's
Oh,
why.
excuse me.
Yeah, they are most of them absent today. They don't have
need the
power.
class note.
Yeah.
I need the
So,
class note from
oh yeah, sure. Yeah, I can send out. Okay. And
no,
also,
from session 11. I need the class note.
Oh, section 11. I don't know. I saved or not.
Okay.
Sometimes I forgot to save. Right. Today's I will never forget. Okay. I'm gonna save it. And also, I'm gonna record right now. Okay. I'm gonna record right now. Maybe if you need record, I'm gonna find out. Maybe I'm gonna put this one on YouTube. Okay, not public, just private. Okay, only our students can see that. Okay, I can put over here on YouTube too. Okay, okay. Everyone, come back over here. 6:10. Okay, 6:10. We'll continue second section. Okay, 6:10 p.m. Okay, take up some break. Okay. Okay, this I'm gonna pause. Okay, pause. That's fine. Okay, have some break. I'll see you in second section. Okay, that's fine. Okay, this is sine 55 degree equals x over 20, right? Anyway, this 55 is half of this angle, right? This angle is a central angle. This angle is by inscribed angle, half of that, right? So we're gonna apply trig functions. So I don't know, you guys learn trig, right? Sine is opposite over adjacent, which is 20 adjacent. So in this case, x is how much? 20 times sine 55 degree. Okay, so I'm gonna use my calculator, okay, not calculator. Okay, can you see? Oh, a lot of students, no power. So we have 20 times, okay. Now check out the mode is a degree mode. Now this is a radian, degree mode, okay. Degree mode. So 20 times sine 55, okay, sine 55. Yeah, they give us the length, okay, 16 point, nearest tenths, okay. Oops, where is it? disappeared. 16.4, right? Okay, 16.4, nearly 10. 16.4. Okay, that's it. Okay, another one. Explain why any parallelogram that is inscribed in a circle must be a rectangle. We have any, to say any quadrilateral it was. Some of this one is always 180. The other ones are also 180. We know that, right? But when you have parallelogram, okay, parallel. We have to find the parallel here, right? Same length. This is okay. Parallel means always what? Opposite. These two arc is congruent. The other arc is congruent. That means what? What that means? Parallel. This is a parallel. What that means? These two angles are 180. We know that, but to be parallelogram, they should be what? Equal, right? They should be equal. Why they are equal? Why? For this length arc. Just explain, okay? For this length arc, like our techno. Can you see that? Okay. In the parallelogram, okay? In parallelogram, if this length is what? Same thing, okay? This length is BB, okay? Same length, okay? Because they are parallel. Just before I told you, when you two parallel line, always opposite lengths are equal. It's okay? Opposite lengths are equal. So this arc for this, A plus B. This angle for this arc, another A plus B. Measure angle, arc AB, measure angle AB. Same angle, right? Same angle. But opposite angle, sum of these two opposite angle is 360, but same angle, 180, I'm sorry. Sum of opposite angles are 180, but they are equal, each one is 90, right? That's why. Okay, right. That's it, okay? Okay, now I'm gonna summarize up to now. I'm gonna, on the class note, I'm gonna summarize, okay? Just first one, summarize what is that? Inscribed angle. Inscribed angle is half of a central angle, that's it. Another one is what is that? All inscribed angles for the same arc are congruent, right? That's the first one, okay? We are talking about inscribed. The second one is what is that? When you have a quadrilateral, right? It's inscribed a circle. We said this quadrilateral is cyclic. Then opposite, sum of opposite angle, okay? We can say, I'm gonna write down. Sum of opposite angle is always 180, okay? That's the second. We just finished these two, okay? All right, now go back, let's work. The next one we are learning inside length of chord, okay? Take a look over here, inside. Intersecting chord. We have intersecting chord over here. The rule is if this side is A, the other side is B, the length. And this side is C, this side is D. The rule is what is that? The rule is what is it? A times B equals always C times D. That's it. That's the rule. Okay? A times B equals C times D. I'm going to write down in the class note the rule over here. Okay? That's the third one. Third one over here. We have two intersecting line over there. Two intersecting line. This is A, this is B, this is C, this is D. I told you A times B equals C times D, right? That's the rule. Why? I'm going to make a two triangle. You can use these 2 points and the other 2 points. You can use this. Or you can make it this way. It doesn't matter, okay? Come on. Okay. And make this two. Can you see that over here? This is what for the same arc AB. These two angles are inscribed for the same arc AB. They are equal, right? They are equal. Can you see that? They are equal. On the other side, we have arc CD over here. For this arc CD, I want different color. Okay. These two angles are inscribed angle for the same arc CD, right? Can you see that? Right? So finally we can see triangle, I'm going to P, triangle ADP. Triangle ADP and triangle CDP, CBP. They are similar, right? They are similar. Can you see the angle similar? You need two angles congruent. All angles congruent, it doesn't matter. So which is the corresponding side? Which is the corresponding side? I'm going to different color. This side, you have the same angle. Oh, this is the same angle. This side, they are corresponding side, not A and B, okay? A and D corresponding side. Because the same angle over here, isn't it? From here to the same angle, AD are corresponding side. Also what? Same angle. Oh, CD is also corresponding side. CD and corresponding side. We know that A and D and B and C, they are corresponding side. It's true, right? Now we need similars. You know that in similars, corresponding sides are in proportion. We know that, okay? So A over D and the C over B, they must be equal, okay? Same ratio, okay? Now let's make a cross product, okay? Cross product. What happened? Finally, we can show the simple form. AB equals CD, isn't it? AB equals. Now we got the theorem over here. Okay? For example, if we have a two chord section, this is 2, this one is 8. I'm going to, this one is 5. What is this side? Oh, we know the formula, okay? We know the formula. 2 times 8 equals 5 times x. This, right? That's formula. 16 equals 5x. X equals how much? 3.2, right? That's it. Just use formula. Okay? We proved already, okay? We proved already. Just use formula. Another one. Example. I'm going to this one. Yeah. Now let's find the example. Intersecting lines. Intersecting lines. One more. We have diameter. When you have diameter, when you have draw a chord which is perpendicular this diameter, okay? What happened? These two lengths are equal, isn't it? That's okay? You have to memorize, okay? Because what? These two triangles are congruent, isn't it? Side, okay, radius equal. This is equal to another side, and this is a reflexive equal, right? So side, side, side. Okay? All right. So diameter is what it is. When you have a diameter, okay, always what? Not this way, okay? Perpendicularly bisect. Okay? Perpendicular bisect. So we can write down over, okay? If a diameter I thought to spare. Diameter perpendicularly bisect a chord the diameter, the chord is always what? Perpendicularly if a diameter okay, a little but change, okay. If the diameter is perpendicular to a chord, okay, then the diameter bisect the chord. You know what that means? This is perpendicular always what? This diameter bisect the chord, half and half. That is okay? So for examples, we have this one. We have a diameter. Oh, this is the perpendicular. Oh, this side is 4. The other side is 9. Okay? The other side is 9. What is the length of this one? Can you find this one? Okay. Anybody can give us the answer? What is the value of x? What is the value of x? We applied by intersecting lines in a circle always by A times B equals B times C. But the point is on the circle, right? That's what we're going to extend it over here, okay? But this perpendicular means what? Always bisect the chord. The other side is also x. Okay, now we can apply the theorem, right? X times x, x squared equals 4 times 9 is what? 36, isn't it? So what is the value of x? X equals 6. And also this is what same as what? Right triangle proportion, right? This is a right angle, isn't it? Because what? The triangle built on circle over here, okay? Or diameter, okay? So you know that when you have this one, right angle, if this is x, how much? If this is 4, this is 9, what is it? X is how much? X squared is 4 times 9, same as this one, isn't it? Okay, same as this one. Okay, that's all, right? This is all. Very simple. When we intersecting lines in a circle, always what? We use this formula, okay? A times B equals C times D, okay? This is a very special case. This is A, where is B? Oh, same length, the other side, okay? That's it. Okay, now we're gonna have some more practice on this intersecting line, okay? We already intersecting line. So we're gonna go, where is it? Here. So I'm gonna choose some they use the angle. Okay, I'm gonna do this angle later. Where is the side? Where is the second? Okay, here's exercise 4 here. I'm gonna try this one. Okay. So we have two intersecting lines. A is 6, B is 4, D is 3. C, oh, so easy. We just know that. We just know that the formula. What is that? 3 times x equals 6 times 4, isn't it? That's the formula, right? 3 times x equals 6 times 4. Okay, so x is how much? This is, we know that, 24, right? 24 divided by 3. 24 over 3, 8. That's it. It's very simple. If you know the formula, right? Just apply the formula. It's nothing. It's nothing. It's nothing, okay? Now the next one, oh, this is a perpendicular means what? Diameter, okay, perpendicular and chord already they are bisect each other. These two lengths is already equal. We know that. Okay? All right, they said over here. Yeah, we did already, okay? Oh, the congruent, yeah, side angle. What is it? Actually, side angle. What is that? Hypotenuse, left, congruent hypotenuse in right triangle. Okay, this is hypotenuse, this is left. Okay, all right, that's always congruent. Now over here, diameter is 20. CE is, this is 4. Diameter 20, or radius is 10. That's the middle, right? Radius 10. Okay. So what is the length of AB? Can you find the length of AB over here? I'm going to make big. Can you find the length of AB from here to here? The chord? Yes. Radius 10. This is for, how much is this one? 10 minus 4 is what? 6. Isn't it? That is just 6. This one from here to here is what? 6. We know that. 10 minus 4 to here, that is 4, 6. This is how much? Radius 10. This is how much? This is, we know that right angle, which is 6, 8, 10, right? This side is 8. So the other side also 8. Total is how much? 16, right? That is the answer. Okay, now the next one I'm gonna call intersecting angle. I'm gonna try. Now we saw what we did, intersecting chord. Now we're gonna learn one more, intersecting. Over here, this is chord. This one we did. This one secretly chord. We did this already. Another one is what? Angles. Angle. So we have 2 angles over here. Oh, red color. Okay. So we have this. Okay, this A, B, C, D. Oh, these 2 chords what? Create what? Intersecting angle. This we said intersecting angle. This is also same angle, right? X. Okay, that is the intersecting angle, right? How can you find the intersecting angle? We're gonna use center angle, right? I'm gonna use this one. A degree means what? I'm gonna do red color, okay? Black. Much. This measure arc is 8 degree, okay? This is what it is, center angle, isn't it? This is center angle. I'm gonna write down on the arc. Actually, this is what it is. Measure of arc, AB, same thing. Okay, this is 8 degree. On the other side is what measure of arc, CD equals B degree. I'm gonna set this way. It is okay? By using this to AB, how can you find the intersecting angle? Oh, very simple. If you know this one, circle is nothing. Very simple. Once you got center angle, think about inscribed angle, okay? Okay, I'm gonna make it, this one, okay, I'm gonna make inscribed this way, or the other way, it doesn't matter, I'm gonna make this one. Oh, this angle is inscribed angle for arc AB, isn't it? Arc AB, right? That's inscribed. I'm gonna inscribe arc AB. This is 8 degree, the other angle is what inscribed angle. What is that? Half of that, right? Half of that. 8 degree over 2. That's what. Very simple. Now we're gonna use this center angle B degree. Where is it inscribed angle? Here. Right? That's right. Because the same arc. Yeah? As we did, this inscribed the half of B, which is what B degree over 2. That's it. That's it. Very simple. So how can you find the other angle or this? I'm going to take this angle, same angle. This angle is what? This intersecting angle actually what is that? Exterior angle. You know this intersecting actually exterior angle. Exterior angle. How can you find the exterior angle? Sum of two removed angles. This one and this one removed angles. B over 2 plus, I'm going to use like A over 2 first, okay? That looks easy. I'm going to use A over 2 first. A over 2 plus B over 2. That is intersecting. I'm going to do one more time. X equal, because this is the X, the same angle, right? X, which is what? Intersecting angle, X equals, what is that? Simplify. Base is what? Numerator, denominator 2, right? So A plus B over 2, isn't it? What is this? What is this? When you have a two center angle, A and B, this intersecting angles is what is that? Sum of this center angle and divided by 2, which is what? Average of these two angles, right? Which is what? Average of the center angles. Very simple. Yes, just average or sum of the angles and divided by 2. That's it, for examples. Circle 2 intersecting inside, okay, not outside, okay? We just finished inside. This angle is 30 degrees. That is what? Measure of arc AB, okay? Measure of arc AB, which is the center angle, but we cannot see the center of it, right? We cannot see the center angle. Okay, so measure of arc. You don't need it. Okay, center. Okay, the other angle is what? Measure of angle CD, right? Actually, that is the measure of angle CD equals 120 degrees. Because this arc is longer than the other one, right? Around 4 times. There. So what is the measure of this angle? This is intersecting angles. By the definition, x equals how much? Just what? 120 plus 30, or 30 plus 120 and divided by 2. 150 divided by 2 is 75 degrees. Oh, this is a 75 degrees. That's it. Okay? This is the angle inside while using intersecting angles. Okay? That's it. Very simple. Now, I'm going to finish by outside intersecting angle. Okay? Outside. Oh, how can you find out where is outside? This is two angle. Number 2, number 3. Angles in outside of a circle. we have two sides outside. The line is not intersecting inside. Then when you make wow, we have outside of this is outside intersecting angle. Still we have what? Two intercepted arc, right? CD. This measure of always this side is what? Gradient small side, okay? Because we have what? The other side we have intersecting, right? Not this one, okay? So this is the measure of angle AB. This is the measure of angle CD, right? Now how can you find this? Just before what? A plus B. I'm going to take this as A degree. I'm going to take this is B degree. Just before what? A plus B divided by 2. But when you have a right intersecting angle outside the circle, it's very interesting. It's going to be what? Can you guess? Yes, you can guess. Inside plus, outside is the minus. A degree minus B degree over 2. That is outside intersecting angle. Very simple, right? It's so easy, what isn't it? Very interesting. So circle is a lot of interesting property there. Why this is true? Why A minus B over 2? Still we use the exterior angle, same things. We just use over here exterior angle, right? This is also exterior angle. Same as before. We use the inscribed angle. This is also we will use inscribed angle. Where is the inscribed angle for this one? Oh, we can make this one. Right? This is inscribed angle, isn't it? This is inscribed angle. How much is that? Half of the central angle. A over 2. A over 2 degree. A degree over 2. That is inscribed angle. Oh, I'm going to find another inscribed angle for the what? Arc CD. Where did, oh, we already have over here. You don't have to make a line. We already one over here. Now this inscribed angle is what? Half of this central angle, okay? So B degree over 2, isn't it? Can you see that? Now which one is exterior angle? This is exterior angle. I'm going to use different color. This angle is now exterior angle. Where is remote interior angle? Oh, this angle, interior angle, right? Non-adjacent interior angle, isn't it? Can you see the formula? Exterior angle equals, what is it? So I'm going to write x plus b degree over 2, right? Sum of this non-adjacent angle equals what? Exterior angle. That equals a degree over 2. That's it. Are you guys with me? Finally, x is how much? Minus b over 2. Minus b over 2. Finally, you got this one. X equals a degree over 2 minus b degree over 2. Simplify 2 to the what? A degree minus b degree, isn't it? Can you see that over here? We just use what same as before. But this time, the exterior angle is a little different position, right? For examples, we're gonna have some practice, okay? I have example. Circle. We have outside exterior. Oh, this is like 100 degree. The other side, 40 degree. That means it's central angle, okay? If you use 100 40, but it's not clean. That's why we don't use, okay, inside center angle, okay? So when you use right outside the number, that means what? Equal to center angle, okay? You know that. So what is the value of x? Oh, formula, 100 minus 40 and divided by 2. 60 divided by 2 equals 30 degrees. Oh, this intersecting angles is what? 30 degrees. Very simple. Okay, now we just finished via some angle too. Okay, I'm gonna finish now the angle, because inside we have okay intersecting chord inside. I'm not gonna finish this one, okay, because we did right angle outside. Now I'm gonna finish, okay, intersecting side or intersecting point is outside. Take a look. Inside is, we know that AB, this point inside the intersect, okay, CD, what is that? A times B equals C times D, that's okay, right? Now we have this intersecting point outside of here, outside, this point, P of here. Oh, how we use this formula? Now we cannot use this formula anymore because we have point outside. How we solve this one? This is A. This is B. This is C. All the way down, there is a D. Okay, the formula is this one. Already you have to measure from point P, okay? Not this one. This is wrong. So what is it? A times B equals C times D. That's it. Or you have to, already you have to measure from intersecting point. That's why A times B equals C times D. This intersect over here. A times all the way down the other point. C times all the way down the other point, okay? That is AB equals CD. It is okay? Why is this true? Yeah, this is true. How? Can you make angle AB make this way, right? Another one. Two lines. I want to make another line over here. Oops, what is that? What is that? From this arc AB, where is inscribed angle? These two inscribed angle, right? These two is inscribed angle. Is it okay? What is for this arc? These two have what? Inscribed angle, right? Is it okay? So this is a common, isn't it? This is a common angle, right? Angle. So what is it? Triangle. I'm gonna use this ABCD, right? I use it. This is lower. This I'm going to use it. This is little c. Little c. At this point is what? Large, big C, okay? Big D, right? Yeah. Can you show me your triangle BCP and triangle ADP? Okay, this triangle, okay? Can you see that? This large triangle, the other triangle, they are similar, right? Because this angle is common, the other angle is common, right? Angle congruent, isn't it? They are similar. So what is the corresponding side? A and C is the corresponding side, okay? Because short, maybe I'm gonna make it separate. This one. This one, right? Okay, same thing. You can see there, okay? So corresponding side, A and C corresponding side, okay? For this triangle, there's a short one, but it's a short one. So A over C corresponding side. Okay, on this A is what is there? The side on this triangle, the side on this triangle. That's right? Okay. This is D is what for this same triangle. Okay, now same triangle, D over the other triangle is what? B, isn't it? Corresponding side B. They must be equal, right? Same as before. What is this? A times B equals still C times D, right? From the similar. It is okay? For example, almost done. This is all about circle. Very simple. This is 3. This is 12. You gotta be careful, right? 12. This is P. Okay. This is 2. And what is the length of this side? Oh, we have right intersecting point outside. About that is about what? Length. The formula is what is that? 3 times from here all the way down, right? 15, isn't it? From here. 2 times all the way down is how much? X plus 2, right? So this one, okay. Just a few more minutes, okay? I'm gonna make it easy. I'm gonna make this one, yes. This too long, this too long. Nine, okay? 9. So 3 times, then it's 3 plus 9, okay? That is equal to 2 times x plus 2. So 3 plus 9 is 12, that is 36 equals 2 times x plus 2, isn't it? So divided by 2, this is what? 18, right? 18. So what is the value of x? 18 minus 2, 16, right? X equals 16. So this is 16. This is wrong. What is wrong? If you go this way, 3 times 9 equals 2 times 16. That's wrong, right? They're not equal. Always you have to measure from this point. 3 times all the way down is 12. You have to multiply this 12 to the 3, okay? That is it, okay? When we have outside intersecting point. Now we did an angle 2, right? Okay, angle 2, we done. We are all done. That's all. That's all about circle, okay? We finished the circle. Just we have a practice. Just we have a practice. Over here, which is it? We have. I saw some angles. Where is them? You saw some angle over here, right? Okay, they just prove it. Okay, this angle is what the GHE, right? This angle, what is it? This angle is what? We need this angle, okay? It's okay? This is intersecting angle for these 2 arcs, isn't it? That's why GE, we need what? GE over here, right? GE angle. And the other one is DF measure angle, okay? So what is the average? That's it, we did this one. Okay, take a look. We did, okay, this one is what is it? This is a 126 degree, BD is 126. What is the measurement there? AC. This measurement. How can you find this one? This is intersecting, it's a 90 degrees intersecting, right? Now I'm gonna find X. Because we have inside the intersecting, what the formula? X plus 126 and divided by 2, that is intersecting angle, which is 90 degrees. That's it, right? Okay, now times 2. X plus 126 equals 180, isn't it? So when you subtract 126, x equals how much? 54, right? This measure of angle, AC, equals 54. That's it. Okay, I just used the formula, isn't it? This is formula where we intersect it inside. Where is another? Where is another? Oh, not many. Okay. Oh, we have exterior angle, okay? We have our exterior point outside, okay? There's one more over here. When we have, this is we set out point when you make the line, okay, on the circle 1 point, not 2 points. This line, the name of this line is what? Secant. The name of this line is we said tangent. Secant has what? 2 intersecting here and here. Tangent has only 1 intersecting over there, right? This is tangent. There's another tangent. At the same point, this is we said exterior point. When you make right 2 tangents, they are already equal. It's okay? They are already equal. Why? This is what it is. Already equal. Why? This is right triangle. Hypotenuse common. This is one of the legs. They are equal, right? So hypotenuse leg, okay? By the hypotenuse leg, these 2 triangles are congruent. So corresponding side also congruent, okay? So these 2 tangents always equal. When you have, we're gonna have some practice. AD is 4. This is 4. Tangent. BF is 1. 6. CE is 1. 7. What is the perimeter of triangle? Oh, this is the same. This is 4. Same tangent. Okay, from the same exterior point. This is 7. The other tangent also 7. This is 6. The other tangent is 6. That's it. The total is how much? 13 plus here 11 plus here 10. Okay, so 31 is the perimeter. Okay, 31 is perimeter. Okay, this secant, this is the same thing. At this time, this is what? It was before A, B. Where is B? B is what move over here is actually equals to A. A equals B, same thing. But this is same as before C and D, right? The formula, what is it? A times B, oh, AB equal. So A squared equals C times D, isn't it? Because the other side, B, is actually equal to the A when this secant move to the what? Tangent, okay? This formula is very simple. Okay, I think that's all, okay? That's all. We're gonna have a little more practice for next week, okay? And next class, okay? It's very simple, okay? So we finished all topics we finished on circle, all topics, okay? You just have some practice, okay? So what type of questions are there, okay? All right, that's it. Okay, so I'm gonna send you this class note to everybody, okay? And also I'm gonna put this in YouTube, okay? When I finish my job, I'll let you know, okay? I'll give you the link, URL code, okay? All right, thank you so much. And I'll see you next time, okay? You have to try your homework, okay?
All right, thank you.
Okay,
have a great day.
Okay, bye. Okay.